multimeter? Suppose tomorrow you are going to start a company like Mohan Aditya, you want to start a company, right? And you want to set up your design office. And design office will obviously require a lot of instruments, right? And one of the instrument will be multimeter. So you will go to the market and how will you buy multimeters? What will you ask the seller of multimeter? What will you ask him? Give me a digital multimeter. Give me 2 kgs of multimeter. Bhaiya 2 kilo multimeter de do. Will you ask like that? No. What will you ask him? What is the specification of a multimeter? You are all using multimeter? What is it classified as? So it can measure voltage, current and resistance. But what is the accuracy of those instruments? By the way, multimeters have lot of insight into them, very interesting features. I am going to discuss them with you. But before that, how will you choose multimeter for a given application? How do you choose? Okay, tell me, what do you see on that multimeter when you use it? Suppose you are measuring resistor and you don't connect any resistor. What display does it show you?
0.
If it shows 0, that means it is 0 ohm, but you are not connected the 2 leads to anything. If you have a multimeter and the 2 leads you don't connect to any resistor, the open, then the value it shows on the display is 1. One leading digit becomes 1 leading and the rest are all blank. That means this is over range. What does it mean? It is over range. Okay. Now the question is, what are the total number of digits on that display? In the multimeter that you use, what are the total number of digits on that display? Maybe what I can do is, I can go to this and search for image. Okay. You see this? You see this? Do you recognize this? This is what you see? You know what are they called? No, they are called DMM, but what more? So it seems can you get me that back? Escape in the laptop. Okay. No, not that. We want that writing pad. Wait. I got it. I think it is this one. Yeah. Okay. So how to select a DMM? This DMM that you saw, it is called 3.5 digit multimeter. Have you heard of this term? Which year you are on? First year? Second year? Okay. You have not heard of this term? 3.5 digit multimeter? No? Okay, now you are hearing it for the first time. Never forget it in your life. That the multimeter that you use in the lab, cheapest multimeter that you get in the lab is called 3.5 digit multimeter. Why is it called 3.5 digit multimeter? Because there are 3 full digits that you saw in that display. 3 zeros is showing. Apart from that, on the leading digit is either a single display 1 or nothing, and there is a minus sign. Alright. Now, what is the resolution of, so this is a digital multimeter. That means inside what is there? It is measuring analog voltage but is showing in digital form. So what should be there to convert analog values into digital values? What is that device called? ADC, analog to digital converter, right? Now analog to digital converter has a certain resolution. You know what is resolution? That is, when you give it an analog voltage, in how many bits does it convert that analog voltage into a digital number? How many bits does it give you? That is called the resolution of that ADC. You all know this? No? No. See, if I have a 1 bit ADC, suppose I have a 1 bit ADC and I give it a voltage, what will it give me? Result, what will be the result? Either 0 or 1, which means there is a threshold value. Less than that will be 0, above that. Suppose the range of the multimeter, range of that ADC is 5 volts, right? So the threshold will be 2.5 volts. So anything less than 2.5 volts will be 0, anything above 2.5 volts will be 1. Now let's increase the resolution of our ADC. Let's make it 2 bits. What will be the 2 bits of ADC? 4 values. What will be those 4 values? 0, 0, 0, 1, 1, 0, 1, 1. Right? Now what will be the 4 thresholds? So 5 volts, it will be divided in 3 thresholds so that there are 4 bands. See this. So in this case, if I have, this is 5 volt and this is 0 volt, and you have this is 0 volt, you have 2 bit ADC. So there will be 1 and 2. So this value will be 0, 0. Then this value, voltage in this range will be 0, 1. Then there will be 1, 0, and there will be 1 more, and they will get 1, 1. Okay, there will be 3 bands, total of 3 marks, total of 4 bands. Is it a good ADC? No, it's a very bad ADC. Better than before. Now to have a very good ADC, what do you require? More accuracy means what? More number of digits. So instead of 1 bit, 2 bit, 3 bit, 4 bit, you should have as many number of bits as possible, isn't it? So if you have an 8 bit ADC, what is the resolution? What is the, if it is an 8 bit number, what are the values of those of that ADC? From 0, 0 to 255. 2 raised to power 8 is 255, right? So it has, what is the resolution? 1 part in 256. Total values are 256. So the resolution of ADC is 1 part in 256. Correct? Likewise, please tell me that for this digital 3.5 digit multimeter, what kind of ADC will be required? Can you do some calculations? For a 3.5 digit multimeter, what kind of ADC, what resolution of ADC will be required? Okay, let me tell you. So if the value is, if you have a 3.5 digit multimeter, maximum digit value will be 1999, right? This is the maximum value. Can you have a value bigger than this with 3.5 digits? No. What is the minimum value you can have? No. It is minus 1999. So what is the total range from minus 1999 to plus 199? What is this range? It is about 4000, right? So you need a ADC which has a resolution better than 1 in 4000. What is that ADC which will have a range better than 1 in 4000? It will be 12 bits. How? 2 raised to power 12. How much is it? 4095. 2 raised to power 12 is 4096. Okay. So in a 3.5 digit multimeter, what kind of ADC is used? 12 bit ADC is used. Now, is there a better multimeter than 3.5 digit multimeter? Like you are running this company, right? You want to do precision work. So precision work means what? Means it should give me a better voltage reading, better precision voltage reading, right? So what will be the better multimeter than this? if I have a 3.5 digit multimeter, what will be a better multimeter than this? 4.5 digit. So now for 4.5 digit, please tell me what will be the ADC resolution required. Calculate. So let me help you. So 4.5 digit means 19999 minus 19999. So total range becomes about 40,000. That means 2 raised to power 16, because 2 raised to power 15 is 32,768, which is less than what is required. So the ADC in a 4.5 digit this is called 4.5 digit multimeter, and this will use a 16-bit ADC. Likewise, what do you think the next better multimeter should be? 5.5 digit, 6.5 digit, 7.5 digit. Now if you go for 6.5 digit, what will be the ADC? Please find out. All of you calculate 6.5 digit multimeter. What will be the ADC required in a 6.5 digit multimeter? 22 bits. Let's calculate that. 24 bits. 6.5. So that is 1999999. This is 6.5 and minus 1999999. How much is this? 40 lakhs. Pakka 40 lakhs or more than 40 lakhs? It will be more than that. 20 lakhs. So 40 lakhs. So what will be the ADC required? 22 bits. Pakka? So this will require 22-bit ADC. Now tell me, will 3.5 digit be more expensive than 4.5? Will 4.5 be more expensive than 5.5, or the other way around? Obviously, the more resolution you have, that ADC will be more expensive, and therefore that multimeter will be more expensive. So remember, whenever you are going to set up a company, or whenever you are going to establish a research institute where you are going to have measurement instrument, you are going to select the measurement instrument based on what kind of measurements you are going to do. Based on that, you will decide, is 3.5 digit multimeter okay for me, or am I doing more precision measurement? I should go for 4.5 digit multimeter, or 5.5 digit, or 6.5 digit, and so on. And as the resolution increases, the cost of the instrument goes on higher and higher and higher, very high. In fact, it rises exponentially. If you go for a 5.5 digit multimeter, it will cost you 2 lakh rupees. If you go for 6.5 digit multimeter, it will not be twice, it will be 10 times, 20 lakh rupees. Okay, so you have to be very careful when you say I want a 5.5 digit multimeter or a 6.5 digit multimeter. Alright, so will you forget this? This is a very important topic. If you cannot measure your voltage accurately, you cannot do any electronics. Okay, is this good? Alright. Next topic, What is power supply filtering? What is power supply filtering? Means when you are making a circuit, all the components that you are using, whether it's a transistor or whether it is an op amp or whether it is a whether it is a microcontroller, there will be a supply terminal, right? Okay, by the way, let me ask you, what is the world's highest selling IC of all times? See, you all follow cricket? Huh? Cricket you follow or football? Cricket, okay. Who is the highest century maker in the world? Sachin Tendulkar. See, you know the answer. What is the highest selling IC of all times? You are all electronics engineers going to be, right? You should know this. You are never going to play professional cricket, but yet you know who is the highest century maker of cricket. You say Sachin Tendulkar. I agree with you. Now you are going to be electronics engineer. You should know which is the highest selling IC of all times. Okay, before that, when was IC invented? You are all using ICs, no? I saw so many hundreds of projects, IC. Who invented IC in which year? Huh? Jack Kilby. Which year? 1959. 1959, Jack Kilby. Which company he worked for? Texas Instruments. Texas Instruments is the company I told you yesterday, right? We have a MOU with Texas Instruments. So, Jack Kilby worked for Texas Instruments. He was a young engineer in 1959. He was supposed to go on summer vacation, but because he had just joined the company, they said you can't avail summer vacation, work in the lab. So in the lab he got the idea, can I put a resistor, capacitor, transistor on a single substrate and make some circuit? So he made a RC phase shift oscillator on a single substrate of silicon, and that is how IC was invented. He patented it. How was Jack Kilby honored? For his invention, how was Jack Kilby honored? He was given the Nobel Prize in Physics in the year 2000. So many years later. Okay? Anyway, which is the world's largest? So ICs have been made from 1960 onwards. What is the age of ICs now? 63 years. Okay? In 63 years, obviously there must be some IC which is selling very high. What is that IC? Just search. You are all sitting with your mobile phone. Just search highest selling IC of all times. 555. Ding, 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 ding. He gets the right answer. So highest selling IC. Highest selling IC. Have you all heard of 555? Have you heard of 555? No? All those who have heard of 555, raise your hand. You see, you are all heard of Arduino. All those who have heard of Arduino, raise hand. See, everybody has heard of Arduino. But you should first hear about 555. 555 is a magic IC. What is it? Magic IC. In 8 pins, it can do magic. That is why it is world largest selling IC even today. When I say largest selling IC means from the time it first came out in I think 1971 till today. That means in about 52 years there is no other IC which has sold more number of pieces than 555. Must be very magical, no? Must be very, oh, Kamal, Jadoo, that kind of IC. That is 555. Anyway, so I am not here to talk about. Okay, great, sir. So you have a multimeter and you have resistor, and what else you have got? You have got that file? Can you find? No? We'll find, sir. We'll do some jugaad. You know what is jugaad? Yesterday I showed you, right? Put that mic in this, so we'll have to do something like that. Okay, let's do a jugaad. Help me with that. So first of all, I will call your sir. You trust him? Okay. Okay, can you do, sir? Can you do one more thing? Yes. Can you get an LED from the lamp? I'll show one more magic with LED. Why are you all laughing? Anybody that you don't know, it is safest to call them sir. You are laughing because of that? No? Okay. Why are you laughing? Why are you laughing? So far. Every day for good health, every day you must walk 10,000 steps. Okay, I am helping that person to become very healthy. Okay, that's the reason. Don't laugh. It is for his good health. Alright, so you trust your sir? Huh? So you will believe whatever I show him and he says? Okay. So I believe this is a 1 kilo ohm resistor. So I put it in the 2 kilo ohm range and I am going to measure the value. How much is it, sir?
0.97.
So here the resistor is 979 ohm. First of all, tell me, it's a 1 kilo ohm 5%. Is it in the range or not? 979 ohms. Is it in the range? Yeah, red LED?
I don't know, sir, but they get. Sir,
Red LED? Okay, we'll find out. So 979 ohm, is it in the range or not? No?
Yes. Yes, it is.
If it is 1 kilo ohm, 5% of 1 kilo ohm become 50 ohm. So it will be between 950 ohm to 1050. Okay? It is 979 ohm, that means it is very much in the range. Okay? Can I show you a magic? Right now it is 979 ohm. I will make it exactly 1 kilo ohm. Will you believe me? Huh? What will you call me? If I convert this multimeter, convert this resistor to 1 kilo, what will you call me? Magician? I will first convert it into 1 kilo, then I will teach all of you how to become magician. Alright? Give me 2 minutes. I'll go outside and then come. Okay? Come. See, I am going without any resistor. Don't think I have taken the 1 kilo with me and I'll come back and say, oh, 1 kilo. I am taking him with me so that he is the witness. Okay, wait. So we have gone outside and we have done something. Sir, what is the value of resistance now?
1
No, or
0.021.
1020 ohm. So from 979 ohms, I did something and it has now become 1020 ohm. And see, not only him, even our friend, he also witnessed. You saw? So now you tell me what sort of magic I did. I could not control myself. That is why it went above 1 kilo ohm. I promised that I'll get a 1 kilo ohm resistor, right? Exactly 1 kilo ohm. It has become 1 kilo ohm and 20 ohm. So what did I do? What do you think I did to this resistor? I slapped it. You know what I did? I slapped it. I said, do more. And its value became increased. Do you think I did that? Temperature, you think if I increase, then now it is back again, it should be something, it is still 1 kilo ohm 22 ohm. See yourself. So no temperature. I went briefly. Okay. Now what is the value of resistor? What it depends on? The formula of resistance. R is equal to rho into L by R. Right? L by R. L by A. R means radius. A is also related to A. Now, one way of increasing resistor is I pull it further. increase the length, or reduce the cross section area, resistor will go up. So you know what I did? I went outside. Outside there is a rough surface. I rubbed the area, the cross section area against that rough surface. So what happened was the cross section area became reduced, the resistance went up. But with this trick you can increase the resistor value, you cannot reduce it. You can increase it, but you cannot reduce it. Anybody wants to try it out? Is there anybody want to try it out?
Yes.
See, magic should not be the only I can do it, you cannot do it. Then that becomes I am Baba. Only Baba can do magic, you cannot do magic. If it is science, then everybody can do it, right? So would you like to try it? Anybody would like to try? Anybody would like to try? Raise hand. तुम try करोगे? आ जाओ. So what we'll do is first measure this. Okay? Then I'll ask you to go out and rub it and come back. ज़्यादा मत rub करना, ठीक है? ये देखो अभी है 974. Okay, what you know what you इस सर के साथ जाओ, इससे नहीं होगा. वो वहीं से रब करके इससे थोड़ा रब करा के लेके आओ. आयरन से नहीं होगा. जाओ go. And LED magic? Yeah, let him come back and show LED magic.
Yes.
974. You have not done much. You will rub harder. ये बीच वाला पार्ट में ना रब करने का है. ऐसे वो जो रेड एरिया है उस पे और रब करके आओ. अभी सिर्फ 1 ओम बढ़ा. 974 से it became 975. But you should do more. Okay, you are ready for second magic?
Yes, sir.
Okay. Okay, second magic is you all use LED. What is it used for? Producing light, right? You can convert electricity into light. What if I told you that LED can be used to sense light also? Meaning what? Meaning, if you put light on the LED, it should give you a voltage. Will you believe me? Or you think I am a magician? Magician? Huh? No, it's not. तुमने जोर से खींच दिया. Very good. ये तो ओवर रेंज हो गया. ये बहुत ज़्यादा मेहनत किया लड़का. 4.92 किलो. ठीक है, समझ आ गया? See 4.92 किलो. It cannot decrease. No, not decrease. So, if you want to increase all your money, give it to him. He will rub it and give it. From 1,000 it will become 4,000 rupees. That's my time. Okay? Okay, second magic. So magic is LED which produces light can also be used to sense light. Okay, first of all, let me show you. I have not come from Delhi with my own multimeter or on my own LED, right? That friend got this LED. So let's first of all check, is it a LED? Let's check. How do you check whether it is a LED or not? In the multimeter, there is a diode test. So I am going to put it in that, and now you see this is LED, red LED. Okay. Now I am going to make a sensor out of it. Meaning what? If I put light on this, it should give me a voltage. If I put more light on it, it should give me a higher voltage. Okay. Let's see this magic. Sir, please come. Now can you read the voltage?
Yes.
How much it is?
0.002.
0.002006 say 2 millivolt.
It is varying, yes.
Varying. Okay. Now a flash, yes. Flash put on this. Sir, please read this voltage.
1.42 volt.
1.428 volts. I'm not joking. You can have a look. Give me a- No, I Is that? You have made a sensor out of a LED. You can make a sensor out of. You want to see? Come here. Here they go. See, this is in the voltmeter range, 2 volt. Now I am putting light. How much volts you are getting? 1.4 volts. But don't think of this as a solar panel. See, अपने bedroom पर text with cross of LEDs. रात में उससे flashing light बनाएंगे और दिन में voltage convert करेंगे. That is not possible. It is sensor. Meaning, if it sense, if you try to draw current, then the voltage will fall. In a solar panel, if you try to draw current, it will not fall. It will give voltage also and current also at the same time. But in a sensor, it will give current or voltage, not both. So don't think that okay, let's coat all our roof with LEDs. During daytime, we'll make a solar panel, and in the evening, we'll do fancy lighting. Not possible. Okay? This is a sensor. Okay. Now, if you want to know more about it, I have written an article on. I didn't invent it. I read it somewhere, then I experimented and I wrote some articles about it. You can search for it. Let me search it for you. See this one, this article you can download. LED sensors and displays ambient light intensity in November 2006. Dhananjay Gadre. Okay. This is a very good magazine called EDN. Here. You can read this article which shows how does a LED work as a this is a circuit I have shown how to test it. And these are the references I used when I wrote this paper. See this. Alright, so today what have you learned? Till now. What is the specification of resistors? Then how to choose a multimeter appropriately. Then how to increase the value of the resistor. What is resistor tolerance? And fifth thing, LED as a sensor. Okay, let's do one more thing, and then I'll go because I have a flight to catch. So, what is the common feature in all the LEDs or all the ICs? What is the common feature in all the ICs? What is it that you can tell about any IC that is true for all the other ICs? That at least you will have a IC which is like this. Maybe this is the block diagram. It will have one VCC and one ground, right? What are other combinations possible? No, for ICs. You may have a op-amp. What does op-amp require? It requires two voltages. It is called plus VCC and minus VCC. Okay, let me give you a third type of IC. You are all using Arduino? You know what is the IC that goes inside an Arduino? Very good. That IC is called ATmega 328, right? If you look at the data sheet of ATmega 328, you will find that IC requires two supply voltages and two grounds. And you know what are they called? They are called DVCC. One pin is called DVCC and the other is called AVCC. And then one is called D ground, DGND, and the other is called AGND. What does it mean? So, you know what is this type of IC called? What is this type of IC called? So, what are the type of circuits do you have? All the ICs that you see, how can you classify those ICs in what types? So, you can classify them like this. There are some ICs which are analog ICs, right? Give me an example of an analog IC. Op-amp. Op-amp is a analog IC, okay? Like op-amp. Like 741. Then there is a type of IC called digital IC. Give me an example. Give me an example of a digital IC. 7408. Very good. What is your name? Suvarna. Very good. She has given correct answer. What is this 7408? AND gate? AND gate? It's an AND gate. So this is a digital IC. Now there is a third type of IC. Can you guess what is it called? It is called mixed signal IC. What does it mean? An IC, some part of it is analog, another part is digital. And you know what? All the major companies which are coming to your campus for giving you jobs. Give me a name of a company which came to give you a job. Analog Devices. You know what kind of company Analog Devices is? It's a mixed signal IC company. What is it? Mixed signal IC company. They are making some ICs which are purely analog, some ICs which may be purely digital, but most of their ICs are part analog, part digital. And this microcontroller that we just saw, ATmega 328, it is an example of a mixed signal IC. Why? Because that IC has ADC inside, and ADC is an analog to digital converter. So that part of the IC is analog. Rest of the IC, CPU, memory, PWM, UART, that is all digital. So it's a mixed signal IC. And for mixed signal IC, the characteristics is that there will be 2 or 3 supply pins. One of the supply pins will be for digital part of the IC, another supply pin will be analog part of the IC. So they are called DVCC, AVCC, like that. There may be multiple pins, DVCC1, DVCC2, AVCC1, AVCC2, possible. But usually DVCC1, DVCC2, AVCC only. Right? Now if you have analog part and digital part, they still require 5 volts. Analog part also require 5 volt. Digital part also require 5 volt. And you have a single power supply of 5 volt. How will you connect? How will you connect? So let me show you. Suppose you have this IC. This is your IC. This is your power supply input coming. This is your USB 5 volt plus 5 and ground. Right? And here is your DV. Let's call it DV because we are short of time. And let's call this AV. And one is DG and the other is AG. So how will you connect? So what you will do is you will take this, connect it here, connect it here, connect it here, connect it here. Is it how you do? If you do this, then shouldn't the manufacturer also done the same thing? Internally you should have just connected the two, given you one pin. If he has given you 2 pins, there must be some reason. Okay, so you should not connect a mixed signal IC power supply, even if they are same voltage. You should not connect them like that. How should you connect? Like this. So this is your VCC 5 volt. This is your ground plus 5 ground. Okay, and here is your IC. DV and this is AV and this is your DG and this is your AG. You know how should you connect? There should be one track which should go from here to here. There should be another track coming from here parallel and it should go here. There should be one track going from here to here. There should be another track going from here to here. There should be separate path. Let me give you an example. Let us say you live in a colony. Hey girl, you are laughing on some joke. I am telling you, you are laughing on that joke. Don't laugh. So let's say you are living in a colony. You are living in a house. And neighboring, there is a butcher khana. You know what is butcher khana? Kill animals. They are killing animals. So let's say, where do you get your water from? Here, where do you get your water from? Krishna, great Krishna river, right? Now, let us do the following. Let us bring one pipe from Krishna river, give it to that butcher khana, and let's extend the same pipe to your home. No? What should you do? Bring a separate pipe from Krishna to your home, another pipe to butcher khana. Why? Because when that pipe comes to butcher khana, that water in that gets corrupted, and some of that corrupted water can enter your home. You are, say, pure vegetarian, you don't like non-veg water. Okay? Here also is something like that is happening. So what is happening is, power supply coming from here is go to digital circuit. Now digital circuit is very noisy, right? Because it is always, the clock is always transitioning from 0 to 1, 0 to 1, because of which it produces digital noise. Now that digital noise comes on the power supply pin, and if it is connected to analog VCC here, then that noise will go from here to here. Okay, so that is why you should not connect them together. You should have a parallel path. Is the water dirty here? No, it got dirty because of this fellow's activity, so you don't want to touch here. But if you have a parallel path, here it is still very fresh, very pure water. Alright, one more thing you should always do, but you won't know. You know why you won't know? Because you are using ready-made modules. It is a Chinese fellow who knows, you don't know, because you are using ready-made module made by China. But when you go inside that module and try to understand what is the circuit required to make it, then you will learn. And what you will learn is that in this circuit you should connect very near to this, you should connect a capacitor like this, and here another capacitor you should connect like this, and then these two capacitors will filter whatever noise that may be generated because of that activity inside that circuit. This is called decoupling capacitor. What should be the value? Typical value is 0.1 microfarad ceramic capacitor. For every power supply pin, connect a 0.1 microfarad ceramic capacitor very close to the power supply pins. There is lot of mathematics and logic behind this, and unfortunately we don't have time to explain that to you. If I come here again, I will explain all the physics behind it, that why is it needed. Secondly, here also you will put two capacitors. See, you will put one capacitor like this, and you will put another capacitor like this. Do you see the difference between the two capacitors? Huh? What are they? Huh? Why are the two capacitors shown differently? They are shown like this. See, one is this and the other is this, and actually they are put in parallel. And you know what are the values? This is a electrolytic capacitor. This will be typically 100 microfarad, and this will be ceramic capacitor 0.1 microfarad. Now when you put two capacitors in parallel, what happens? Their value gets added, right? Is that the purpose here to put, do I want 100.1 microfarad? Is that the reason why I put two capacitors in parallel? Remember, like resistor, capacitors also have tolerance, and there are poorer tolerance. Like a capacitor typically will be 20% tolerance or 10% tolerance, which means if it is a 10% tolerance, already the 100 microfarad value will be anything between 90 to 110 microfarad. So putting a 0.1 microfarad ceramic in parallel to add to that value, no effect. Then why am I putting it? You know why? Because electrolytic capacitor is not just an electrolytic capacitor. You have heard this, na? Buy one get one free. This electrolytic capacitor is like that. This electrolytic capacitor, if it looks like this, it is actually equivalent circuit is like this. This is the equivalent circuit of a capacitor. So this is that capacitance C, this is that C. But you get a R with it, this is called ESR. Do you know what is the meaning of ESR? It stands for equivalent series resistance. Then you have a ESL, equivalent series inductance. And then you have a equivalent parallel resistor. So for a electrolytic capacitor, you get too many other problematic things with it. And those problematic things, that inductor in series, the resistor in series, make it a useless capacitor at high frequencies. Because at high frequency what happens? The capacitance impedance goes down, but the inductive impedance increases. So it cannot filter noise at high frequency. So what we do? We put a ceramic capacitor whose equivalent circuit model is much closer to the capacitor. There is no series inductance and capacitance with it. But because the value is very small, it is useless at low frequencies. It becomes effective at high frequency. So rule of thumb, in a circuit when the power supply comes, put a 10 microfarad or 100 microfarad electrolytic in parallel to 0.1 microfarad ceramic. And then that power supply terminal track is going to every VCC. There, very near the VCC terminal of every IC, put a ceramic capacitor of 0.1 microfarad. And why you should do that, why you should have parallel tracks for analog and digital, that I will discuss if I come again with you, for you here, or you come to Delhi, or if you, I told you, right, that there is a lecture of mine on this thing, where? NPTEL, let me show you, NPTEL Gadre embedded. Did I not tell you yesterday? Here, see this. This is my, you see my face, same guy? Same guy. So I have a course on NPTEL called Introduction to Embedded System Design, and there is another guy with me, Badri Subudhi, but he has not given any lecture. He is my key, pass key, RFID tag to enter the room. You know why? Because NPTEL is a club of IIT faculty. I am not in IIT. So I had to enter that club. What did I do? I took a IIT guy with me, come, let's enter the gate. Oh, he just helped me enter the gate. All these 40 lectures, all of them are mine. In one lecture, he is there for 5 minutes. Okay? So you can see these videos. In this video, in one of the videos, I have discussed what is the logic behind putting the two tracks separately for analog voltage and digital voltage. You can find out in which, I don't remember which video. Otherwise, when I come here, your teachers call me here again, I will discuss this. What is the logic behind putting two capacitors on analog and digital separately, and how to put two different tracks, parallel tracks, to go to the input of the power supply. I will discuss it whenever I am here next. Alright? Any questions you have about any of the things that I have discussed? Was it useful for you to come on a Sunday and attend 1 hour talk here? Or do you think it was a waste of time? Okay, alright. Any questions you have? No? Shall I go? Okay, thank you very much. What is the
example
Atmega 328? Download the data sheet of Atmega 328. You will see that there is a analog VCC supply terminal and digital VCC supply terminal. And if you actually make a PCB using that IC, you will have to follow this technique that I am telling you, that you will have to draw parallel tracks to the power supply input. See, I have few suggestions for you. So you are all done excellent by having this exposition, and you made your circuits using ready-made boards. But very importantly, it is very important for you to go inside those boards, those modules, to understand how they work, right? Now, where is all this knowledge available? Whatever they will teach you is only maybe superficial. They will give you terms and all, but what is the depth? So there is an excellent book I am going to write down here, so that all of you should get that book, and you can easily get a pirated soft copy very easily. Okay, I am going to write that book name. Please download it today. It is a 1300 long pages book, but it is full of knowledge. You know what is called osmosis? What is osmosis? So because of flow of material through membranes, right? So I keep telling that when you go to sleep, you have a pillow, right? You should buy this book and use it as a pillow, and maybe by osmosis, knowledge from that book will go into your brain. It is such a wonderful book. Okay. When I started my career in 1989, I was 23 years old. I had just finished my MSc. Next day, I told you yesterday, right? Next day, I got a job. With my first salary, I bought this book. That book is still going strong. 34 years later, that book has become 3rd edition recently. That book is called The Art of Electronics. Have you heard the name? I will write down the name. So this book is like the, Gita. Whenever you have a trouble, emotional trouble, you refer to Gita or to your other religious books, right? It is like the religious book of electronics. Whenever you have a fundamental problem, you find a solution in this book. It is and first edition was written in 1981, second edition was written in 1989, third edition was written in 2015, and even today third edition is here, but second edition is also very useful, first edition is also very useful. So I recommend that all of you should get this book. You download so much e-books and all, and you never refer to them. I know this is what happens. So I suggest you download it, and every day you should open that book for at least 2 minutes. Read some new topic, and you will become very, very enriched and a real engineer when you read this book. At least this book. There are many other books also, but in a short period of time I can tell you, please refer to this book. Second edition is also available ebook. Third edition is also available ebook. There is a lab manual also available with second edition and third edition. There is a X files name third edition here. So 5-6 books are available. Whichever book you get, second edition or third edition, download them and please refer to them. I am very sure you will become better electronics engineers. All the best to you and good luck.
Thank you, sir. So our department would like to extend the thanks and a token of gratitude by presenting the short to you, sir. So I would like to welcome our HOD on the stage, please.
Okay, see you. What time I should be leaving? By 5 o'clock? 6 and 5 o'clock. Otherwise I was thinking if there is some salary shopping. Please, we are very happy. Yeah.